All right, your notes may say 10.3, but this is definitely section 11.3, logarithmic functions. Today we're going to look at logarithmic functions and some of the features of them, evaluating them, changing forms, all of that good stuff. So the first thing we're going to talk about is the logride. These two statements mean the same thing. These two statements are equivalent. The first one is written in logarithmic form, and the second one is written in exponential form. Sorry, my handwriting is not very good right now. To transfer from one form to the other, we're going to do something that I like to call the logride. You start at this base. First of all, this says log base A of x equals y. So you might want to write that down. Log base A of x equals y. Notice x is the same size and in line with the log. The base A is smaller and slightly below subscript from that line. The y, the equals y, is also in line, same size as the log and the x. Start with the base A, and woo, we do this logride. In class, I'll go through like why it's called the logride. If you're curious why I call it the logride, shoot me an email. I'll let you know why. But we flip around, start at the base, go to the other side of the equal sign, and then around. If you notice, the letters in exponential form are written in the order that that line I just drew touches. So A raised to the y equals x. You can also go backwards into log form if I do the logride. Woo! The woo is mandatory, by the way. Start with the A. You've got log base A of x equals y. So it follows that same order when you do that logride. So I use the logride to help me switch from form to form. A couple of definitions. A common logarithm just looks like log and then a number, letter, whatever. Notice there's no base shown on that logarithm. A common logarithm is base 10. You don't actually write the base. It's kind of like the 1 that's in front of every x. If you see log of something with no base shown, that means it's base 10. The natural logarithm is called ln, and it has a base of e. So log base e is the same as writing ln. Or every time you see ln of something, you know that that ln really means log base e. The log and the ln buttons on your calculator are common log and natural log. So the log button on your calculator is base 10. The ln button on your calculator is base e. Use a calculator to evaluate the function at the indicated value of x. Round to 4 decimal places. So this first one, basically they're asking us to do, I'm just going to write it out, log base 10 of 100. So in your calculator, log button, 100, you should get an answer of 2. B, they're asking you to do ln of 16.8. So find your ln button, 16.8. You should get 2.8214. I'm writing 4 because the next digit was 7. It was 0.82137. So that 7 bumped the 3 up to a 4. In example C, they want us to do log base 10 of 0.0001. So log button, 0.0001. You should get -4. Okay, the borders of this table aren't shown, but basically we're filling in the table. So they did the first one for us. They changed log base 2 of 8 equals 3. If you do the logride, woo, that is 2 to the third equals 8. So they wrote it in exponential form. We need to fill in the blanks. So, woo, this is 2 raised to the -3 equals 1/8. Next one we have is in exponential form, so woo! start by writing log. This is base 10 of 10,000 equals 4. Okay, ln is log base e. So if you need to write a little e down there, woo, e to the 2.079 whatever equals 8. So now let's imitate that. ln means base e, woo, e to the negative 0.405 ... equals 2/3. And then going the other way, woo, we've got log base e. So if you want to, you can write log base e, and I would count it right, but log base e is the same as ln. So log base e of the number 148.4 ... equals 5. All right. The change of base formula, technically, you can say that you are changing something into base 10, but really this is just a way that we evaluate logarithms, because the buttons on our calculator are log, so common log, and natural log. We don't have, like if I asked you to do log base 2 of 10, we don't have a button for log base 2 in our calculator. So we have to use this change of base formula. So if I want to do log base 2 of 10, using this formula, I would do log button, so log base 10 of 10 divided by log button 2. So I'm going to put some colors on here so you can kind of see what's going on. The base and then the number in the base, or inside the log. You do log button of the number in the log divided by log button of the base. You could also use the ln button for this. So same thing, you do ln button of the thing in the log divided by ln button of the base. Honestly, I just don't use this at all. I just always use my log button. That way I don't mess it up and I don't press the wrong thing. Because if you do log button on the top and ln button on the bottom, that would royally screw things up. So I would just ignore the base e and just focus on base 10. So use your log button, the one that says log, to evaluate logarithms. So if I want to evaluate these, we would do log button 32 divided by log button 2. If you're using a scientific calculator, your log button is right below your second button if you're using the normal scientific calculator that we all recommend that you use. If you're using this graphing calculator, it is right next to the 7. So I want to show you how it looks when you plug it into a calculator, because it is important to close your parentheses. So if you push log button 32, you need to close your parentheses before you divide by log button 2. And you should get 5 as your answer. So this is 5. This means that the log base 2 of 32 equals 5. If we wanted to, I could go a little bit further and say, hey, check this. If you do the log-ride, 2 to the 5th is 32. And if you know anything about 2 to the 5th, that does indeed equal 32. But ultimately, we're looking for, what does this equal? It equals 5. So I want you to try doing these next two on your own. Pause the video, try the next two. I just want to show you what happens if you don't close your parentheses. If I do log button 32 divided by log button 2 without closing my parentheses, that is not the correct answer. So please, please, please make sure when you are doing change of base, when you're using the log button to evaluate logs, close your parentheses. Okay, on B, we should be doing log button of 5 divided by log button of 5. You can probably guess what that's going to be. Log button 5 divided by log button of 5 is 1. The next one, we need to do log button 1 divided by log button 9. It is not the bigger number on top, it's the number inside the log on top, and it's the base on the bottom. So log of 9 goes on the bottom because 9 was the base for that logarithm. And this one is 0. Pause the video, try example 4 on your own. On your assignment, it's going to say round, I think, to 4 decimal places. On your test, it's probably going to say 3 decimal places. Just remember to look at the number that comes after that. So the first one in example 4, our answer would be 2.4534. We would just cut it off there because 4 after that means leave it be. And then on this one, negative 4.6439. That 5 would give that 8 a shove up to 9. 5 or above, give it a shove. 4 or less, don't mess. All right, so those are our answers for that example. Okay, we can do these using your calculator. There's a lot of ways to do this. Basically, they just want to show you some interesting properties here. So hopefully you're getting fairly familiar with doing this log, this change of base thing. So on A, we would do log button 1 divided by log button 5. And our answer is 0. Basically, they're just trying to show you that if you do the log, doesn't matter what the base is, but if it's the log of 1, like try just log button of 1, you get 0. So it doesn't matter what the base is, the log of 1 is always 0. To do ln of e to the 5th, we do ln. Remember, e it's above the ln button, so you'd have to push the ln button, second ln to get your e, and then type in your 5. You end up getting 5. Okay, so basically, if your base and the number inside the log match, it's just going to be that exponent as your answer. And this kind of should make sense because if you do the log right here, woo, e to the 5th equals 5. Or sorry, e to the 5th equals that whole thing e to the 5th. So basically, if the base and the number inside the log match, your answer is just going to be that exponent. This one, it would be negative 4. And C kind of tells you why. If you do log button 3 divided by log button 3, you get 1. If the base and the number inside the log match, that thing equals 1. So this thing equals 1, and you're left with just 8 as your answer. Now you can type this into your calculator. Log button 5 raised to the 8th, close your parentheses, divided by log button 5, close your parentheses. Your calculator will tell you 8. So when in doubt, you can plug all of these into your calculator. Okay, that is the end of the first video. The second video will go over the graphs.